Hello, I want to walk you through an example of tonight's homework. These are still BCA tables, but they have a few extra steps. We want to be very careful that we write the balanced equation, that we identify every piece of this process with the units. Remember, those really matter, and that we show our work. So this first one says, using a Hoffman apparatus for electrolysis, a chemist decomposes 36 grams of water. So we'll start with water, decomposes into its gaseous elements. So that would be hydrogen and oxygen. Remember, those are a part of Hofbrinkel. That means they can never be written alone. So this H and this O would need a little 2. They also referred to as gaseous, so I can use a little g to show that they were gases. Next, I have to balance the equation. So let me put a 2 here to balance those oxygens. 2 oxygens before, 2 after. uh, 2 here to balance the hydrogens, and then I just like to put a 1 there to keep everything looking neat. Go back to the question, 36 grams of water. That's how much there was before, so now I have to stop here. In a BCA table, we can only ever use the units moles. It really matters. We cannot use the units grams, so I'll have to change grams into moles and then do the BCA table. This is the extra step. So 36 grams of water times. Now, what is the rule? When I change grams into moles, it's kind of hard for me to remember the rule, but I know if I multiply it by a ratio, it's easier for me to remember how to set it up. Because the thing that I want to finish with, which is moles of water, goes in the top of the ratio, and the thing that I want to cancel goes in the bottom. Then I only have to remember what that ratio is. 1 mole of anything is equal to its atomic mass. So the atomic mass for water is just the weight of the H's and the O's. H weighs 1.0079 on the periodic chart, and oxygen weighs 15.999 on the periodic chart. So I'll just plug those into my calculator, double the H's, and add the O. And the weight of water is 18. I like to move it, move it. I'll go ahead and plug that in. Now, students always ask, why do I set it up this way? Well, most chemistry teachers set it up this way for a few reasons, I'm sorry. We start with the number that we've been given. We multiply by a ratio. It will always be a ratio, so you could do yourself a favor by writing multiplication and then a line to prepare to write in the ratio. And then the ratio will always have the thing that you want to solve for on the top, which in this case is moles of water, and the thing that you want to cancel on the bottom, which in this case is grams of water. Because if you have grams in the numerator and grams in the denominator, they will cancel and you'll be left with the unit moles. But what is that ratio? Well, remember, 1 will always go with mole, because 1 mole of anything is equal to its atomic mass. So I'll take 36, multiply by 1, but it's still 36, so don't be confused by that, and then divide by the molar mass of water. The number that I get is 1.9. It's very important that you write the units moles and water because we just did all that work to turn grams into moles. Now, how many of those digits should I write down from my calculator? If you would like to write them all down, that is fine. You can do that. What we try to do in chemistry is we try to round to about the number of digits that we were given in the problem. If the problem gave us a 2-digit number, we try to round to a 2-digit number all the way through. Let's go ahead and plug that in. How many moles of products do we have before the reaction occurs? 0, 0. Now, during the reaction, we'll assume that all the water changes because we don't know any different. And then to fill in the change line, remember we divide by the coefficient above. 1.9 divided by 2 is 0.8. Then we multiply by the coefficient we want to fill in. That will make this 1.9, and that will make this 0.8. So we'll just plug those in. To go back and check our work, we want to make sure that the ratio on the balanced equation matches the ratio on the change line, right? So 2 to 2 to 1, these two numbers should be double whatever this number is, and we know it's right. Then we'll simply add and subtract to fill in the after line. So there's 0, 1.9, and 0.8. So what's the thing we were asked to find here? How many grams of hydrogen should she get? How many grams of hydrogen? So that's this number, but it says grams. So the last step for us will be to change 1.9 moles of hydrogen into grams. Every time we change grams to moles, we'll set up a ratio multiplied by a fraction. The fraction should have the thing we want in the top, we want grams, and the thing we want to cancel in the bottom, we want to cancel moles. The ratio is always 1. The 1 goes with the mole because 1 mole of anything weighs its atomic mass. So how much does H2 weigh? It weighs double the mass of H. So over here in my calculator, I already had it. 2 is double the mass of H. So 1.9 times 2, 3.8 grams of hydrogen. That is my final answer. Make sure I circle it to let everyone know that this is my final answer. Technically, this wasn't my final answer. This was just a step, right? Because the question asked for grams, so the final answer is in grams. And then I'm just going to kind of put this work over here in the corner. Yes, you have to show this work every time. It's important that it be there so that the teacher can check it, but you could put it in the corner neatly if you'd like. And I've got my answer, 3.8 grams. So you go ahead and try the next few.